So hello everybody, we are back after our break. So now we are going to see robot framework, how to automate testing, which I believe is super important because like I commented, I don't want to break the network. So how can I make sure my testings are always run and I have some consistency. So let me introduce you to Maciej, who is going to deliver the presentation. So Maciej.
Hello, everybody, and welcome to the session on Developers Days. This session is about robot framework. It's really basic. It will give you only the introduction to what robot framework is and how it can help you to deliver your quality and to be sure that your projects and your NSO deployments are working fine at each stage of the process. I will start with some introduction to what automated testing is. Then there will be some examples and few things on how we are using robot at Cisco. I'm working in this business for almost 20 years, mainly for the vendors. 10 years at Cisco now in professional services. Now it's customer experience, doing all kinds of NMS and OSS automations. And when you do this, usually you want to also be sure that your quality is right. And this was one of the things I've tried to automate. But before we go to that part, please think about what you like most, the thing that you spend your free time, your hobby. For me, it's sailing, and I love to go sailing for a day or maybe a week, maybe for 2 weeks. Usually, I cannot get more PTO at one time. But there is one thing that always bothers me and keeps me unhappy at the beginning of each cruise. It's the checklist. The things that you need to test before you go to be sure that you are safe and everything go well. You need to test sails, engines, steering, all this kind of stuff. It's a really long checklist. It usually takes you half a day to do it. And usually all those things needs to be done to be safe. What I would like to do is to automate, but I cannot. We don't have yet humanoid robots to do it. But in our business, in software, we do have. There is a robot framework which we are using a lot at CX to test the deployments. But first, what's automated testing? What it is, how we define it. First, we need to ask a basic question. What is the testing? What you want to achieve? What's the definition? How you think you can do it? I have my definition, which came from a lot of experience. For me, it's a set of actions that you perform to verify system behavior. Yeah? To be sure that the system you design, you deliver, is what is expected. Simple system, yeah, car, everyone knows it. But if you buy one or if you want to drive one for a longer time, usually you do all those checks. You start with unit tests. You can open, you can check if everything is in place. Car has its all the pieces that you expect it to have. It has the right spec. Then if everything fits, everything matches, that's the integration. If everything is put in place. Functional tests, of course. Can you drive it? Is it starting? Is it running? Is all the functions you expect, like lights, indicators, everything works? End to end. Usually you go for a test drive and drive to check check if it will get you from start to the end of your journey. Of course, there are some less things that are less obvious, like security, maybe safety. It's performance for some people it's very important, for some it's less important. Load also, it depends what you are using the car for. And finally, user experience. That's something that really define many times make you to decide if it's the right car for you or if it's not. All those sections can be always can be applied to software. Unit tests, of course, we check if each part of the software we deliver if it works. Integration, if it works with the other sections. Functional, if it fits the purpose, if the software gives you the functions that you expect. End to end, if it works in the environment you have with other systems. Security, now it's quite crucial. Performance, it's something forgotten. When you get to production, you notice that, oh, we have some issues. Load, similarly. And finally, user experience. Why to test? This is simple. This is probably quite obvious, but anyone wants to answer to that? Okay, so to get the confirmation that functionality you were looking for, you were implementing is there, you need to show to your customer. Probably you want to know this first, that you go to the customer and show him something that he really wants. Non-functional verification, also important, because what if customer gets the functionality he wants, but it has some functional non-functional issues, like the load, like the security. Change and release validation. It's about ensuring quality on each stage of your software deployment. Software is a living thing in these days. It's not that you are delivering the one package, it's tested, and you forget it for years. Usually, before you end your current deployment, there will be new set of requirements that you need to add. Each change, software is so complex that each change can affect functionalities you already pushed. Finally, all those 3 points are getting you to your customer satisfaction, to your ultimate goal, because the customer satisfaction is always what drives the business. You can say it's a business factor, it's a CTO requirement, it's new functional requirements, but all those requirements gets from your customer satisfaction. If it's big company you work for, you need to satisfy the decision makers. If you are working for end users, you need to satisfy them. Somewhere at the end, there is a person who makes the decision, who accepts your work. So it's better to test it earlier to be sure that customer will be satisfied. Finally, why to automate? Because it's quick and easy way to test all the things you do. If you really think about complex systems like NSO with its services, with the environment, with everything that is combined to deliver NSO project, automating is only a small part, but gives you really big benefits, because it gives you ability to test multiple scenarios quite fast. Definitely faster if you would do it manually. Definitely you can test more scenarios and more often than you would do manually, having the developers doing their development tests, or even having the development separate test team to do it. You also can automate regression testing, which helps you with all the changes you do, with all the different, even external packages, like changing Python version, changing NSO version, changing net. Everything is this can all those things can influence your deployment. So this is something that is really worth to automate. And this is something that I learned on my way through the deployments and through different projects. Building automated tests is first review of the common understanding of the requirements. Usually, if you start with building your automated tests in parallel to the system, it gives you a really, really big advantage of going through the specs, trying to understand them by yourself, and discussing it with your stakeholders. This can really, because if you, everyone have their requirements, their specs, they read it, but usually people, everyone is reading it his own way. If you get the same people in the room and show them the list of tests prepared, then they will say, oh yeah, really, we write it, yeah, it's like in requirements, but in fact we thought about something else. Really, you will see that people confused of what they have written, and this really helps to find those issues early in the project, because if you start to build your test scripts at the beginning, you will be easily you can easily find the common understanding of requirements, or even do some adjustments to those, because people will find that the testing is the ultimate way to show that what you delivered is the right thing. So if you agree on testing, you will know what to deliver. Now, why robot? This session is about Robot Framework, which is open source test automation framework with large community and really powerful code base, which helps us to deliver those tests easily. One of the biggest advantages is that it's human readable. If you and test engineers don't need to be really coding experts, because they can easily create those tests without really knowing the programming language. This is the simple test case. As you can see, read it. It's quite obvious what it will do. It will connect to the device. Yes, it will start using the testbed, which contains the device details, connect to one of the device defined, and run the show interface command. The only thing is that there is a variable, which I'll explain a bit later. Robot Framework has very good reporting mechanism, which also I will also present, and it has really large ecosystem of the libraries already available, helping you to use different connections like REST, HTTP, CLI. All those different commands are already created in this manner as a so-called keywords. I will go to that later. And it's as robot is Python based, it's really easy to integrate it with Python. If you need additional keyword that no one from the community already built, you have Python developer, or you use Python yourself, it's really easy. As you can see, you create just a simple Python function with proper annotation, and it will just work. You will import it to your robot script, and it will work. So how to build your robot files? This is the very simple robot file structure. It starts with the settings section, which contains the list of libraries you will use. In this case, it's CXTA. It's Cisco built library. It will have some resources, which are the robot files with predefined keywords that you want to use. It can be reusable. You can reuse those keywords between your projects or your test suits. Then there are two very important words lines. It's suit setup and suit teardown. These are the keywords. That keyword is a function. Okay, probably most of you are more familiar with the programming language. So it's keyword is something that defines a function in a robot. So setup suit is keyword that so function that is executed before your test starts. It prepares your environment. Tear down is something that is triggered at the end of the successful or not, doesn't matter. It will be triggered after the last test to clean up your environment. So you can reuse the same environment all over again. Then we have variable section. It's quite obvious. It just sets the things that you want to test, or if there are things that you are changing during the test, it's good to have it there. And then we have test cases there with and keyword sections. The test cases are the things that we really test. It's defined the way that we have test case name, and then we have those keywords, so those functions we trigger one by one. In this case, we have two very simple keywords which configures NSO, so just runs the NSO command with NSO CLI and do the check command on the device itself. It connects to the device and checks the result. Here is how we define those keywords. It's the example for the keywords that would be triggered as a setup and tear down. As you can see, again, we are pointing to the file which contains the details of the environment. Then we have a keyword that will retrieve the NSO rollback for us to be able to. We are saving this rollback ID to be able to roll back the environment and have it cleaned after the test execution. At the end, we are doing the suit teardown, so we are doing the rollback for NSO. We should get our environment clean after the testing. This is example of the environment definition. We have XR router, and the same way we define any other external device that we use, or external server like NSO. And this is last part. It's how we integrate with Python. As you can see, it's just a Python file which implements a simple class with a function that renders for us the Jinja template with some variables that we can get from our execution, from previous tests, or from a variable file which will be in our resources. Then the keyword annotation gives us the name of the keyword that will be used in the Python, and we have those two templates and variables which will be used. Templates will be the file name, and variables are those which we'll use in the template to have the output file ready. As I said earlier, one of the most powerful things in robot is in its reporting tool. It's out of the box. This report is something that we get after each execution out of the box. We have all the statistics. We can have some tags that will divide those tests for us, and when we drill down each of those tests, we can see some more. We can see some tags and documentation which can be defined in the robot files. Drilling down, when we go to the test to the exact to the log part. This is the log part. The first one was the report. It was high level. Now we can get to the execution logs, which gives us the drill down to each and every keyword we use. So if we go down and we drill down each of those plus signs, we'll get to the our test suite. And for example, we have the first call, which is checking the NSO version. This is something that we can do at the beginning to be sure that our environment is set up correctly. And we can see that the keywords we used are drilled down to the level where we do our CLI call in NSO, and we get response NCS state version 5523. So this is the NSO output. And yes, now I will show some examples from one of the simple projects. Just we reuse these examples in later on in a few other projects, just to have the basic testing at the beginning. I won't go to any more complex example due to time limitation, but we start with platform test. If we want to test the whole environment, it's good to be sure that what we are testing is working, that we are not in situation that we are starting the big test of whole our service platform, but one of the main modules does not work. I don't know, for some reasons packages are not reloading, or we are using the same script for different environments. One of the environments is in the previous software version. So for this, we usually start with some small platform tests to prove that everything on the platform is okay. We can run those tests also on the even on production environment to prove that it's fine. We can test also the connectivity. We can test log files, rollback files, everything, if all those things are properly configured. This is very simple example where we do check NSO version, check if all the packages are redeploying, which is the simplest way to prove that NSO is fine, if the upper state is right. And there are some more tests that can help us to check the health of the platform itself. The simple code example. First, check if RESTconf is running. The testing here was based on the RESTconf. If it's running, we just do the simple get call. This is library call, and check if the response status was 200. Very simple, but very powerful to test if you are ready for your main test part. Similarly, check NSO version. As you can see, there is not too much. There is not too much complexity. You can read it. It's human readable. You can probably, even with no coding skills or very small coding skills, you can understand what those function does. And here are the results. Again, we have this log which shows us that everything went smoothly, and we can check all the details. In case of error, the keyword that was that errored out will be highlighted in red, and you will see the error message. It will be all the green, or all the past tests will be drilled, will be only with the plus, and the one that failed will be drilled down to the error level. With all those details, like what was the exit command and exit code, and what command was executed, what was the result. And now I will move to the probably most important part for many of you. It's about functional testing. This is usually when we look at the NSO, what is its function? It's the software that helps you operate your network, and the one of the main feature is services, to build your services, to create them, to modify, redeploy, and finally delete. And this is what we are usually using robot for. Of course, we can test if the conditional behavior is working fine, which and automating all this helps us to run many more tests and many more test scenarios if the way that we wouldn't do manually. And finally, we can verify if the service is live. If it's the devices were configured properly, we can connect to the devices, check connectivity, do ping tests, or all other tests we can think of. Here is the very simple service. It's just an example. We have L2 VPN service between in the network, and this is how you can really easily test your first service you can build. It's just a JSON file that you will send using RESTconf to the NSO. This is the definition base, the service based on the model I showed previously, and basing on this we can trigger all those tests because we can simply send the JSON payload to the NSO, check the results. This is your first really simple test showing if the NSO is fine, if you can deliver the service to the network. You will again get all the results in the one place. You can store it, you can send it to your dev team if it fails, you can show it to customer. From my experience, there are already few of my customers likes and understands robot, and it helps a lot. If we show them how the test cases looks like and show the reports, it really makes people believe that everything is fine, and we can work faster, not diving deep into all the test cases. And this is what I like the most, the dynamic tests. This is when you try to run your test basing on external data sources. It's like data-driven testing. You can test dynamic environments, you can test different services using and conditional behaviors using the data that you get from the outside world, from databases, from files, from NSO CDB. And this is one of probably my biggest win in my professional life. I was working for one of the biggest banks in UK, and they have NSO. They have also this very secure environment with CyberArk, with one-time password to enter each router they use. There was NSO was building chains of services based on virtual routers, virtual load balancers, firewalls. The chains were created the way that it can be up to 8 devices in the row with the redundancy. So testing one of those chains could take, manual testing could take up to 4 hours, because each time someone wanted to go to the router and do even ping test, he needed to obtain one-time password, then go back to the router, run ping test, go back, get another one-time password. It was crazy. For each one-time password, they need to put their own password. It was the security level was up to absurd. but the customer already agreed that NSO is safe enough to have the plugin for NSO to do all those things automatically. So, and the customer was knew what robot framework is, they agreed to use it. So with very simple tests, we got the details of this service with the Python script from NSO CDB and run those tests automatically using NSO live status. From tests that could take up to 3 to 4 hours doing manually, we went down to between 5 and 10 minutes to do the whole service connectivity test for each of those device chains. So it was really big win, and the customer was very happy with what we achieved. And yes, why? Because automating with robot, you get your test cases, but to really use the power of this tool is to use it in CICD pipeline, where you can trigger your test from the starting from the Git check-in, Git commit, or Git push, and basing on this, you can. In this case, we use Jenkins. You can do the build, set up your test environment, do all your testing. Of course, later on you can do static analysis and release if the test went fine. So this can help you in your in improving your quality, because if you test your code each time you push it to the repository or overnight, it depends on your process, it will really gain the quality, and NSO deployments will be really better. Finally, how we use robot at Cisco. So we have our internal test automation, which is called CXTA. It's robot based. It has some enhancement with other Cisco Python libraries. It started from projects, so NSO was its initial scope, but then it was extended to other Cisco products. Now it has a lot of plugins. We use it usually in our projects to test different. Nowadays it's almost all different types of software used at Cisco can be tested. We have on the top of it, and not only covering CXTA, but one of the things that is covered is CX Test Manager, which helps us to gather all the data, trigger those tests, and as you can see, you can have the list of all the test metadata. You can have the when it was run and what was the result of each test, and later on, if you drill down, you can get again the same robot reports. And what are the services? There are different levels that Cisco CX can help you with the test automation. We can assist you in creating your own test scenarios, your test plans for the and automating those. There is a subscription service that you can use to have the access to CXTM and our libraries, our internal libraries. We can help you with building keywords for your services, and also third-party API integrations. And at the end, there is solution validation service, which helps you to do the complete end-to-end validation for your solution. Okay, so what I want you to remember from this session is that test automation is best way for your success if in terms of your customer experience and happiness, and that's probably most important thing, because automation, test automation helps you to keep the quality on each stage of your journey. If you start building the test automation at the beginning, you will find the weak points or even the misunderstandings or issues in the requirements at the beginning of the project, not at the acceptance, because you will start to look at your acceptance criteria at the beginning of your project. That's the change of the mindset. Automation will give you both NSO and services verification at each stage. Each update, each code change can be tested with no effort. Of course, there is an effort at the beginning to build the automation, but later on you do the change, you push it to Git, or you trigger manually your robot test, and you get the result. You see if it fits the purpose, if it works. It standardized the testing process and quality reports. As you saw, the reports are created. The reports are also created the way that there is XML source that can be uploaded to any other system from robots. So it's not only the way HTML way I presented, but it can be also uploaded to other systems. And yes, robot framework as such is easy. It's does not need too much coding skills, and it's robust and flexible for your testing. Best practice, 3 simple points. Start writing your test at the beginning of the project in parallel to your code, basing on acceptance criteria. Consult the test, consult the acceptance test plan and the test you will be building basing on ATP with your stakeholders at each stage with each change. And test your each code change. Best way is to use the CICD pipeline, but of course you can trigger it. Usually it's just one-liner: robot, your file name, .robot, enter, and that's your test will start. And if it fails, it will fail fast and you can improve it. What's next? Think about your automation, the thing you are working on now, the service, the thing that you need to deliver. Your current project is all about. Find a simple and significant use case, something that you can start with. Visit robotframework.org. There are examples. There is really good manual. There is whole manual how to set up environment, and build your first robot test case. And then you can go for your cruise. Thank you. Also some references to different sites that can be helpful. Yeah. Yes, sure. You can trigger it manually, just triggering your command, because it's, for example, we are using it in the Docker container, which robot is triggered by Python script. So you can use CLI, the bash command to run your tests also. The automated way is the best way, but in a way you will have a change, because if you don't use the dynamic test cases, to add new router, you will add it to this testbed.yaml file to have the username and password pushed there. But if you and for the CICD pipeline, there is always a way to trigger it manually. So if you want to re-trigger the tests, the Jenkins, which we use the most, it has HTTP UI. So you go to a web page and you can just click rerun the test. So there are many different ways to trigger the test.
Okay. So more questions? Yeah. Okay. Well, thanks a lot, Maciej.
Thank
As you
you.
can see, we are taking a look at talks talking about testing, and because I mean you know already, we can deploy from hours to minutes with automation, but we can also break stuff from hours to minutes with automation. So that's why it's very important the testing part. And you saw that we have internal tools, CTM, and if you are curious about this specific product, you are in good luck because our next speaker will talk specifically about CXTM. So we need the microphone for the people that is on the stream. So this is how you use it. Let me turn it off.